Yeah, so basically what I wanted to showcase here is some of the different kind of like use cases of Azure OpenAI, now called Azure Foundry, AI Foundry. So just to give you a little bit brief about myself, my name is Harsh Poda. I've been in like IT industry for like about 18 years. Started as a .NET developer. Um, I started my own company a few years back. So I'm working as a director and co-founder at Veritone Solutions. Still involved with like a lot of development and architecture. Um, have been involved with like a lot of AI-based projects in the last few years. So that's what I wanted to share, like some of the different experiences, different use cases which we have covered. So just going to the agenda, I basically divided like the session in um, like three use cases. So the first use case is basically how AI services can be used to process like some of the historical data. So more kind of like um, converting unstructured data into structured data um, using AI models. Um, this is basically like in conjunction with some of the other services. I'll go more in the details in that use case. The second one is once you have like those historical content or historical documents, basically creating like your like vector database to generate like new content. Um, so the first part is kind of like um, the document processing. Second part is like content generation. And then the third part is basically knowledge extraction using like a AI chatbot. So um, like building on those historical document to allow end users to use like a chatbot interface um, to ask questions and um, uh, provide like more context-aware responses. So this one also uses like the kind of like the RAG model. So um, based on the documents provided, using like different LLM models um, to have like the correct responses um, to to the user questions. Now jumping to the first use case for like using like previous historical forms or documents um, for extracting like the unstructured data and then converting into structured data. So the use case I'm using here is I think of like a property management company. So the way they go about is, there are like, different forms, different documents which they create. A lot of those documents are basically kind of like semi-structured. So it could be like in, a lot of different formats. So it could be like PDFs, PowerPoint presentations, Word documents, all contains like information about the properties, about like in real estate, it is basically it could be like if you think about a property, it could be like number of bedrooms, bathrooms, car parks, floor area, land area, and so some of the same information, and then there could be like some of the financial information in there as well. Um, so it could be like rent of the property. If it's like rental related document, it could be the value of the property. Um, so all of like those different kind of information could be there. But since it is like in an unstructured format, like if there are like no kind of systems in place, those information might not be usable for like reporting purposes or like extracting like more information or knowledge out of it. So the use case here is basically to extract like that information from those documents um, and then putting it into like a structured format, so more kind of like a JSON format. So how we can extract those details from like readable content to a structured content. So um, one option for that is basically using something like form recognizer. But if there are like a lot of like different formats available, then it could be difficult to have like the form recognizer um, providing um, like the accurate structure. So you can get like all the content from the form recognizer, but then you can use the AI foundry or like the AI models to basically convert that into like a more structured format. So then it can be, it creates like a lot more like opportunities from there. Like once you have that content into like a structured format, you can push it to something like Fabric, for example. You can push it into like databases and then create like all sorts of reports of like previous historical documents. You can also create, you use like ML models on top of it. So for um, um, more for creating or calculating like the new values out of it. So I'll go into the code to give you a walkthrough of how this can be done. Um, um, so in this scenario, I've created like a simple application which basically uses the form recognizer to process like a PDF document, and then using a system prompt to convert the output of uh, that form recognizer into like a JSON format. So um, reading the different values and then returning it as a JSON. So I'll quickly show you like some of the sample documents which I'm going to process and how it can be then used. So just showing like few examples. So um, you know, um, some of the say like a rental appraisal document could be like this. There's like a very basic format which I created. Um, so it could have like the address of the property, some description about the property, um, some details which a property manager can write, and maybe like some of the comparable property which they have added. Now they might be creating like a lot of like these kind of documents, and could be like in different formats as well. So there could be they done in like a Word document as well. So no like one structure and like different kind of formats. So these documents then can be processed. So I'll just walk you through the code here. So basically, like giving the file name. So I've loaded like all of these files into blob storage as well. I will quickly show you that. So like I loaded like all these files in a container, and then um, basically this program, when I run it, first I can give like a file name, which can then um, extract the information, just read the content using the form recognizer. Um, so because like we don't have to configure it for like a specific kind of documents, it could be just reading the results out of it. So if I run the program and if I just print it, if I print just the raw output of the document, it is to such certain extent could be like unusable. So there is like a lot of information which comes in from there, which is all the points, all the location of the different content. So there are like ways to parse it, but if the documents are in like different formats, then it becomes like really difficult. So one of the other way could be rather than reading uh, the direct content of it, um, we can read. So instead of raw content, we can just read the actual like text content which it found. Um, so if I use that, it becomes a bit more structured that way. Um, but it's still in the text format. So it's still return like some information which you still need to make sense out of it. So instead of doing that, what if we provide like this input to um, to AI Foundry and then get the JSON format out of it? So in order to do this, we can basically just provide like a system message. So we can say like, if you are like a document extractor, we will give you like a PDF content like obtained through OCR, which will have like, these kind of details. Um, there will be in the document, there will be like comparable properties. There would be uh, different kind of classes. So like it's apartments and whatnot. Um, and then the answer we need is basically in form of a JSON object. And then we define the JSON structure here. We can also provide like some of um, the conditions that if it doesn't found like any information, then it should just return like an empty JSON. Um, and it also needs to combine the comparable property in the same kind of format. So the output which we get is more uh, like accurate a JSON object. So if I take that, print the output which we're getting. So now you'll see the output is a structured JSON, and then it contains like all the like different properties in there as well. Um, this JSON then can be ingested into like any of the services and can further be processed, which makes it like much easier compared to how it is in the raw format. So that's um, I found like a different kind of like use case. So it's like when we think about like AI um, used in like a lot of application, it is more knowledge extraction for the end user, but this could be knowledge extraction or like um, information extraction for the internal like application itself. So we could use like AI for creating the information for the application, which then it can use to process it further. So that's the first use case. So just using Azure's storage, form recognizer, AI Foundry, and could be like just a Azure function to process like all those files one by one. The next use case is basically building on top of it. So um, like you might have seen like property managers basically kind of write like a description of the property, how they see um, they basically add like a few different things about the property. Now this can like usually it is done like case by case basis. They write the complete description. They could be like using ChatGPT or something for writing the description or like updating the description. What if like based on all the previous description which they have written, using that knowledge, using the structured data which we already had from the previous stage to automatically create new um, new description. So based on the information we have about the property and whatever the system kind of learned from like previous type of description, it can generate like new descriptions. So in this case, we'll be just using like AI Foundry and could be like just the Azure function um, to extract that or auto generate the property description. Um, this is more like RAG based, so um, the the AI Foundry would have basically um using like the Azure Search Index, which is done based on the previous document repository which we have given. So just going back to um, Azure portal. So like these are the documents which are provided, um, created like a GPT-4o model um, to basically like index or create index all the documents and then um, apply it like the model, and then using it in the code along with the system prompt um, to generate the description. So going through the code, um, very much similar. Um, so basically, you need to generate the property description. Um, so sorry. Um, so create like a Azure function. I'll run that through as well. But basically, just need to like generate a property description, which will be just using the OpenAI uh, module in Python, calling the um, Azure Foundry using the API key. We provide like the index name and um, basically can have like a a limit um, on the description. So it doesn't need to create like a really long description. It can specify like create up to like 300, 400, 500 words like descriptions. Um, and yeah, that's and basically like providing the prompt to generate the description. So if I'm just gonna run it from the Azure portal. So I have the code deployed in the Azure function, which is gonna provide the details of the property. So say like we provide like an address, the suburb, um, and the details about the property. Now, it would be the OpenAI service would be using all of these to basically generate the description based on the previous descriptions which are there for like similar kind of like suburbs, similar kind of properties, similar kind of like land area, floor area, whatnot. So if I run it, it basically generated more like user-friendly or property manager-friendly description. Um, it can be even extended to a level where because it knows about like which property managers actually created like which description, it knows like about their style of the description, so it can even specify to that extent, so that the descriptions which are generated are more in line with the way they basically generate the description. So um, yeah, it is like more user readable kind of description based on the previous data which we have. Now going to so this is basically kind of like using the AI Foundry in a way that we are utilizing the historical data um, and then creating the content um, for the application. So it would be then used within the would be used like within the application along with like all the other things. So it is more like a generative AI or like content generation kind of use case. Then the third use case would be more for the, just the chatbot. Um, so here we basically, there are like a lot of different frameworks which are available to create like these kind of like chatbots. Um, the one I found like much more easier to use is a NuGet NPM package called dchat. So dchat is um, like an open source um, NPM package available for integration with a lot of like different services. So very easy to configure um, and very easy to use. Um, so um, the source code is available in like MIT license. So it can be like then used like easily within the application. The version I would be using is more like a React version of it. So hooking it into with Azure and basically providing like a system message to give the persona to the chatbot so that um, user can use it, and then we can embed it within the application like in various different forms. So quickly go through um, the code for it. So basically, it will also start with like a system message. We can specify like all the different like guidelines, tones, what we need to avoid, examples, certain questions, styles, notes. So like a good extensive like system prompt. Um, and basically some other like initial messages as well. So if I run the application, so here it comes with the UI. Um, and then it provides like a usual kind of interface for the questions. I'm using the same um, Azure OpenAI service here, so I can ask about a property. Um, so let's say give.
Hey, Hirsch, just like a heads up, we have a few more minutes. So
Yeah, all good. So I gave like an address, and then based on the specification of that property, it would return like comparable properties based on our system prompt and the model which you have created. Yeah, so that's basically kind of the three use cases which I wanted to cover. There are like many more these kind of like use cases, um, but yeah, feel free um, to hit me up on LinkedIn. Um, and yeah, thanks um, for the session, Marcel. Um, it was yeah, very good event, and glad to be
nice.
part of it.
Well, thanks, Hirsch, for coming. I got a question. Like, so you brought like some real examples, right? Some things that businesses could leverage on the integration space. Have you seen like the use of, let's say, the data extraction, for example, or in replacement of other platforms? I don't know, just like your experience on that.
So I was thinking like quite a few kind of use cases now. So like everything from like invoice processing, invoice workflows, to a lot of like different kind of like reportings. So a lot of organizations actually have like different kind of like forms filled in by um, could be like by end users, by like internal employees, and most of the time like those forms are like available just like in those PDF format, or like in just like a structured format. So they don't have like the actual data. So think about like all the different forms that you fill, like even like manual forms that you fill, and then usually they go into the organization. They do like a scan copy of it, and then that's it. Like it just available as form of PDF. Like insurance companies, for example, like a lot of time, you fill out like those forms like on paper, they scan it, and then it is there like as a evidence in form of just the document. So how those forms can be actually processed through um, like not just the form recognizer, but then using the actual data out of it. So even like anything from like sentiment analysis to like a different kind of like reporting, getting like the information out of it. So a lot of like different these kind of like use cases which you've used.
Well, thanks for bringing like your input. That's really interesting. That's your QR codes, definitely connecting to you to check like your source code and examples. Thanks,
Yeah.
Rush. Appreciate your time. Yeah,
Cool.
talk to
Thank
you
you.
soon.